Okay, so we're going to be looking at day 4, limits of trigonometric functions today. So a couple of things that you need to kind of have in the back of your mind that you're going to use are some of the ways you can rewrite trig functions. So remember, secant theta is equal to 1 over cosine theta. Cosecant theta is equal to 1 over sine theta. Tangent theta is equal to sine theta over cosine theta. And cotangent theta is equal to cosine theta over sine theta. So when we're using limits of trig functions, we're going to be using some of these today. Okay, so when we're looking at example 1 here, we want to find the limit as theta approaches 3 pi over 2 of 3 tangent theta cosine theta. So you're always going to try to do direct substitution first. So if we plug in 3 pi over 2, everywhere there's a theta. So we are going to have to use our unit circle. So on our unit circle, 3 pi over 2 is at the bottom here, so that's the point over 0 down -1. So remember, tangent is y over x, so that would be -1 over 0. And then cosine is just the x value, so that would just be 0. Well, -1 over 0 is undefined, so we can't just use direct substitution there. So what you're going to have to do is you're going to have to rewrite our trig function. So just like if it wouldn't work earlier, we had to factor or rationalize or add those fractions, we're going to rewrite. So we're going to take 3 tangent theta cosine theta, and we're going to rewrite it. So using the trig identities that were at the top here, we know that tangent is the same thing as sine over cosine. Okay, so if we rewrite it like that, we know that cosine can cancel because we have 1 in the numerator and 1 in the denominator, and we're just left with 3 sine theta. So now that we've rewritten this, now we can do our limit as theta approaches 3 pi over 2 of 3 sine theta. And now we're going to do direct substitution. Okay, sine is the y value, so we're using the y value up on our point here, so it's 3 times -1. So we get an answer of -3. So this is very similar to when we tried to do direct substitution and it didn't work, when we had to factor or we had to rationalize or add our fractions. So you're going to do direct substitution. If it doesn't work, then you're going to rewrite using a trig identity, and then after that it should work. So for number 2, we're doing the limit as x approaches pi, or theta approaches pi over 2 of secant theta cosine theta over 4 theta. So we're going to try direct substitution. And there are a lot of problems where direct substitution won't work, so make sure you try it first. Okay, so pi over 2 on the unit circle is at the top. That ordered pair is over 0 up 1. So secant we know is 1 over x, so that's going to be 1 over 0. Cosine is just the x value. And then this is just 4 times pi over 2. Well, you can't do this 1 over 0, so this is not going to work. So we're going to have to rewrite. Okay, so we have secant theta cosine theta over 4 theta. Well, using our trig identities, secant theta is the same thing as 1 over cosine theta. I'm going to keep cosine theta. So when you're doing trig identities, cosine and sine are normally just going to stay like they are. And then I'm going to keep the denominator. So these cosines can cancel, and we're just left with 1 over 4 times theta. So now that we've rewritten it, now we can go and find the limit as theta approaches pi over 2, and what we had left was 1 over 4 theta. So now we can do our direct substitution and plug in pi over 2. So we're going to end up with 1 over 2 pi. Okay, so for the next part, there is 2 or really 3 limits that you need to memorize. And I'm going to show you how easy it makes it once you memorize it. So the first one is the limit as x approaches 0 of sine of cx over cx equals 1. So this c stands for a constant. So let's say the constant is 3. You just have to have the 3 there, and you have to have it in the denominator for this to work. So anytime you see this limit, it has to be as x approaches 0. But let's say it's sine 3x over 3x. That will always equal to 1. So this is going to be super important. That's going to be your most common one. The other one here with cosine, not as common, but sometimes it will be. So the limit as x approaches 0 of cosine of c of x minus 1 over that c of x, or the limit as x approaches 0 of 1 minus cosine of c of x over c of x. That's going to give you 0. So not as common, but you'll still see it sometimes. So you need to make sure that you have that memorized. So here's what I mean. So for example 3, it says the limit as theta approaches 0 of sine of 4 theta over theta. So we're always going to try to do direct substitution first. But if you plug in 0 for theta, that's going to go ahead and give you 0 in the denominator, so you can't do that. Well, there's no way to rewrite sine of 4 theta. Okay, so we're going to have to use this property. Well, this property says if there's a 4 here, there has to be a 4 on the bottom. Well, we can put a 4 there. If you put a 4 in the denominator, you have to put a 4 in the numerator though. Okay? So if you put a number in the denominator, you have to put 1 in the numerator. But I'm going to bring out, so remember one of the properties is you can bring out the number out front. So I'm going to bring out that 4 from the numerator out front. So that'll just leave me in the numerator with sine of 4 theta over 4 theta. Well, if you look at this property up here, it says sine c of x, so sine 4 of x, over 4x. Well, that's what I have here. That's always equal to 1. So this part right here is equal to 1, and I just have to multiply it by 4. So that gives me an answer of 4. And that's all that is. So if you see sine with some number theta, just know that you're going to have to put that number, get that number on the bottom. If you put it in the denominator, you have to also put it in the numerator. So if we take a look at 4, the limit as theta approaches 0 of 2 sine 5 theta over 3 theta. So I'm going to try direct substitution, but when I plug in 3 times 0, that's going to give me 0 in the denominator. Okay, so I notice there's no way to rewrite this with my trig identities, but I see this sine of 5 theta. But then I see this 2 and this 3. Well, the 2 and the 3 here are just constant, so I can actually move the 2 and the 3 out front. So this is the same thing as 2/3, the limit as theta approaches 0 of sine of 5 theta, because I got rid of the 2, and then just theta there. So from there, just ignore the 2/3 for right now. If I want to use this property up here, it says if there's a 5 theta here, there has to be a 5 here. So if I put this 5 in the denominator, remember I have to also put it in the numerator. Okay, well that's fine. I just want to move this 5 out. So if you move this 5 out here, you're going to have 2 times 5 in the numerator over 3. The limit as theta approaches 0. All you have left in the numerator is sine of 5 theta over 5 theta. Well, it tells you that the property, this sine of 5 theta over 5 theta, the limit as it approaches 0 is going to be 1. And then we just have this from the outside, which would be 10/3. So the answer to this would be 10/3. And that's all that is. So if you remember this property, this limit of sine c of x over c of x is 1, comes in a lot of handy when you get to this point right here to be able to figure out what the limit is.